we covered this, I don't remember how far back, maybe a couple weeks back in Chem A. Well, we talked about the difference between atoms and ions. Alright, so atoms versus ions, what's the main difference between them? Does anyone remember? Atoms are neutral, yes, atoms are neutral. So we wrote that atoms are neutral, which means that which two subatomic particles are equal to each other if they're neutral? Protons. Yes, so that means that our protons equal our electrons, so all of our positives are being canceled out by negatives, which is why our overall atom does not have a charge. Alright, so an ion is an atom with a positive or negative charge. Atom with positive or negative charge. Alright, and what was the name of a positive ion? Cation, yes, cation. So cation is the positive one, and what's the name of the negative one? Anion. Anion is negative. So now we're going more into ions because we're going into chemical bonding. And that's the whole purpose of ions, is that they lose and gain electrons for chemical bonding so that they can become more stable atoms. Alright, which one, so let's go back to over here. So if I have 3 protons and 3 electrons, I'm neutral because all my positives are being canceled out with a negative. So if I lose one of these electrons, what's my charge now? Positive, positive 1. So to become a cation, it's going to lose electrons. Alright, so if I go back to being neutral, 3 protons, 3 electrons, and I gain an electron, now what's my charge? Negative. So if I'm an anion to have a negative charge, I'm going to have to gain electrons. So do you guys remember talking about that? Alright, so we're talking about ions now, charges. Atoms with a charge. Are we good here? Everybody good? Okay. Alright, so pull out your periodic table. We wrote all the charges, or I think most of you have them already written on your periodic table. If not, you added it in. But you can find the charge of any atom based on the group. So you find the charge at the top of the group. So group 1 is all +1, group 2 is +2. Group 3 through 12, their charges can vary, so we can't assign a set charge to those groups. A lot of those elements have multiple charges. Some of them only have one, like zinc. So have your periodic table out right now. Let's go ahead and write that in. Zinc right here. So on this box, write in that zinc is always going to be a +2. Zinc is always +2. So add that in that box. Zinc is always +2. Does anyone not have a periodic table? Because I have a few copies. I don't have a ton. I have a few. Anybody else? Alright, another one that always has a set charge is silver right here. Silver is always +1. So a lot of times these elements we might use because they don't have the varying charges. They're always a set charge. And then another one that always has a set charge is mercury, +2. But most of the other ones here, their charges vary, so we don't assign a set charge to this whole group. Alright, here we have +3, here we have ±4, -3, -2, -1. Why do the noble gases not have a charge? Jerica. They're stable. They don't want to lose or gain electrons. They're already stable. So they already have how many valence electrons in their outermost energy level? 8. And what's that rule that they're already following? The octet rule. Alright, so we'll keep going here. Alright, we've already done this. We don't need to rehash that part. So let's keep going. Alright, this is what we're going to start by reviewing today. Alright, so let's look at sodium. Sodium has how many electrons? 11, because if you find it on the periodic table, it's Na, and it's got 11 protons, so it also has 11 electrons. So 11 electrons. So if we were to draw an atom diagram of sodium, all right, how many max electrons would go on the first energy level? 2. 2 is the maximum number for the first energy level. How many would go on the second energy level? 8. So 1, 2, 3, 4, 5, 6, 7, 8. How many have I used so far? 10. So how many would go on my third? 1. So that would be my atom drawing. So remember, my first energy level at max can have 2. My second can have 8. How many can my third have? So put 3 in for N. 3 squared is 9 times 2? 18. What about my fourth? 32. Alright, so that's my atom drawing. Alright, so now, valence electrons. Which ones are the valence electrons? The outer ones, right? So how many valence electrons does sodium have? 1. How can we find that a lot quicker without drawing this? The group number, because sodium's in group 1, it has 1 valence electron. Alright, now, sodium's in group 1. What is its charge? Its ion's charge? Plus 1. So sodium down here, I'm going to write is Na plus 1. So what's that mean it's going to do? Is it going to lose an electron or gain one? It loses one. It does the opposite, right? If it's a plus 1, it loses 1. And this is always refers to electrons. Refers to electrons. That's what's changing when we're talking about ions. So which one am I going to lose up there? The outer one, right? So this outer one drops off. So for my ion diagram, I just have 2 in my first, 3, 4, 5, 6, and 8 in my second. My outer one just dropped off. So the octet rule says every atom wants 8 valence electrons. That's why it becomes an ion. So it can either lose electrons or gain electrons to where it will have 8 valence electrons. So did it lose its outer one to where it now has 8? Yes, so the octet rule is basically like the basis of all chemical bonding. Everything wants to have 8. So it's either going to lose electrons or gain electrons to where its outer number, its valence electrons, will be 8. Alright, so if it only has 1 or 2, it's probably going to lose those outer ones. If it has 6 or 7, what's it going to do? It's probably just going to gain a couple because it's going to want to do the easiest thing possible. So it's either going to lose a couple or gain a couple to get to that magic number of 8. Alright, so now let's do another one. Let's do sulfur. So sulfur, find sulfur on the periodic table. How many electrons total does it have? 16. So it has 16 electrons. Alright, so it's atom diagram. How many are on the first energy level? 2. How many are on the second? 8. So 1, 2, 3, 4, 5, 6, 7, 8. I've used 10. So how many are on the third? 6. 1, 2, 3, 4, 5, 6. So would it make more sense for sulfur to lose those outer 6 or to just gain 2 to get to 8? Gain 2. That's going to take less energy because it requires the exact same amount of energy to gain an electron as it does to lose one. So if it would be easier to just gain 2 than to lose 6 of those outer electrons. So how many valence electrons are there here? 6. We could also find that on the group number. So what's the group number for sulfur? 16. So for groups 13 through 18, what do you always have to remember to do to find valence electrons? Subtract 10. Alright, so the ion diagram, well, sulfur, what's its charge over there for group 16? -2. So is it going to gain 2 or lose 2? It gains 2 to where it will now have 8 up here. So instead of redrawing all this, I'm just going to take a different color right here and add 2 more. And now, how many valence electrons does it have? 8. So the whole purpose of what we're about to move into, chemical bonding, is so that all atoms can have 8 valence electrons, which is the octet rule. They want to have 8. And when they have 8, they are stable. Atoms want stability. When they don't have 8 valence electrons, they're unstable. So that's the whole purpose of chemical bonding. All right? So everyone kind of remember doing this? I was trying to give it as like a review, so hopefully if you didn't maybe get it all from Kim A, maybe this was a good little bring it together. All right, so here's what you're gonna do for the rest of class. All right, your first assignment, I've got these printouts, so when you're done, you can turn it in up to the sorter. Atom ion diagrams, exactly what I just did. You'll draw the atom diagram, you'll write how many valence electrons there are, then you'll do the ion diagram, and then you'll write the charge of the ion. Exactly what I just did on the board, okay? When you're done with that, because that should not take that long, all right? When you're done with that, go ahead and start the chapter 6 vocab. Now I posted it in Google Classroom because I don't want you to do every word in chapter 6. So if you go to Google Classroom, well, I am about to post it right now. All right, so if you go to Google Classroom, you look at chapter 6 vocab, there's a slide and it says only do these words. So the words are on page 208 in the textbook that's right here in the front, but only do these words, only these that are on this screen. So I put, you can handwrite them or you can make a Google Doc and type them. But I want textbook definitions. I don't want Google definitions if you type them. I want textbook. I also have the textbook posted in Google Classroom. I just don't have the glossary, which is why you might want to grab a textbook and actually get the definitions in the glossary. But you can go through the chapter and get the definitions too. If you handwrite them, turn them into the sorter at any point. If you type them, just share them with me at any point. It goes directly to my email and I'll get your grade in that way, okay? Let's say that the vocab is gonna be due, today's Wednesday, let's make the vocab due next Tuesday. So I'll give you almost a week, okay? So anytime, and people that have had me before know this, anytime you have an extra moment in class, work on vocab, but I'm not just gonna set aside a whole day for you to just do definitions, okay? So you can do them outside of class and just get them over with, or do a few a day. Do some when you come into class if you want. It's up to you, but they'll be due by the end of class on next Tuesday, before Thanksgiving break, okay? All right, so I'll pass this paper out and then you guys can go ahead and get started.
Do you want me to stop it?
Huh?
The video?
Oh yeah,